Now that we've reviewed what vertical angles are and what corresponding angles are, we can now use what we know about them in order to figure out some other, somewhat more complicated relationships between angles. I hope that you find that this is also easy, but we'll see how it goes. Stick with us. So, we're looking for vertical angles, and can you find some pairs of vertical angles? Stop and think for a minute. Is there a pair of vertical angles that you can identify? And then what do you know about vertical angles? So, if you said that B was vertical with C, you'd be correct. Likewise, if you said that A was vertical with D, you'd be correct. Now, we know that vertical angles are congruent to each other. So that means that A is congruent with D. That is, they have the exact same measure. We know that B is congruent with C. That is, they have the exact same measure. So down here, I'm asking myself, well, what angle or angles are congruent to A? And we know certainly that D is congruent to A. They have the exact same measure because they are vertical angles. They are directly across the intersection from each other. So A is congruent to D. Good. Now, if we look down here, it should be simple for you to also see some vertical angle relationships. We'll come back to vertical angle relationships in a moment. Now let's look for corresponding angles. So we know that A is congruent to D. Can we find the angle that is corresponding with A? That is, the angle that looks exactly the same if we took a picture of the intersection at angle A and then looked at the other intersection where we had these two parallel lines that are intersected by a third line which is obviously not parallel to them. So we're looking for the exact same picture of A and we find it down here at W. Now we know that corresponding angles on parallel lines are also congruent. So that means that angle A must be congruent to angle W. These are corresponding angles. So we know A is congruent to D. They have the exact same measure. We know that A is congruent to W. They have the exact same measure. Very cool. So what about the corresponding angle for angle D? The angle that looks exactly the same as angle D at the other intersection is angle Z. So we would be saying angle D is congruent to angle Z because they are corresponding angles. So these two relationships we found using corresponding angles. That A is congruent to W and D is congruent to Z. Excellent. So, if A is the same as D because of vertical angles, and if A is the same as W because of corresponding angles, what does that mean about the relationship between angle A and angle Z? Are they congruent? Yes. They have the exact same measure. For example, if we said that angle A were 55 degrees, vertical angles would tell us that this is 55 degrees. Corresponding angles would tell us that this is 55 degrees. Then we would say that this is also 55 because of vertical angles. We would say this is also 55 because of another corresponding angle. So we would say D is congruent to Z, we have that. So A is congruent to D, is congruent to W, is congruent to Z. Because of vertical angles and because of corresponding angles. Now we can do the same thing with the supplements, that is, the angles that add to 180 degrees. Sorry, I'm going to erase something really quick. So I said that D is congruent to Z, but we also said A is congruent to D. So this doesn't need to be a double line. This could actually be a single line, because A is congruent to D. just as A is congruent to W. And then this is also actually a single line, because all four of these angles are exactly the same. They are congruent. In this example, they're 55 degrees. So now the obtuse angles, very briefly, we would say vertically we have B with C. We would say vertically we have X with Y. But then using corresponding angles, we would say we have B with X. And we would say we have C with Y. And they are all congruent. B, C, X, and Y because of vertical angle relationships and corresponding angle relationships. Great job, Smarty Pants!